Hi, this is Jiajun Hu. This video is for the Probability Homework 10, Problem 1. Okay, in this problem, we need to collect the definitions and simple properties from the lecture notes of these 7 stochastic processes. So for the first is the Potion process. In the Potion process, we have the formula that the probability is equal to this part from the lecture note, and we have the properties that the intervals t1, t2, and t3, t2 are non-overlapping, then the random variables n are independent. And also we have the image that this is like the probability will increase by t in the Potion process. Then we have the features that the mean is equal to the lambda t because it's increased by the time, so the mean value is according to the t's value, according to the time. And also we have the autocorrelation is equal to this. So in the Potion process, the mean means the Potion process is a linear function of t and matches the common sense, that which means the longer time we spend in the Potion process, and the number of the expected value will be larger. And the autocorrelation, this value is mean the property of independent. The Potion process will be independent. Okay, and for the second one is the Potion increment. So in this part, we have the yt is equal to xt plus epsilon minus xt over epsilon. So which means the xt is a Potion process and the y will be the Potion increment. Well, from this we can know that the y is equal to increment of the basic Potion process. And in this part, because the t will be cancelled, so the mean value of the Potion increments is just the lambda. It's not related to the time. And also we got the mean value and the autocorrelation formula. And this is intro to the Potion impulse process. And also from the autocorrelation, we can see that this part will be a triangular with area lambda, and it is independent of the epsilon. So when the epsilon goes to 0, the triangular will become the impulse, and the whole the whole Potion increment will be the impulse process. And third is a Potion impulses, which means the epsilon be 0, the Potion increment. So the basic definition is that zt is equal to the xt's derivative, where the xt is a Potion process, and also is defined as when the epsilon is closer to 0, the portion increment will be the portion percent imposes. And in this part, we got the feature that the mean value is the lambda, which also same as the portion increment. And the autocorrelation part will be this. So it's easy to understand because, well, the ZT is imposes, and which is, as we discussed before, the portion imposes part is just similar to the portion increment part. So the autocorrelation part will be a triangular with the epsilon equal to 0. Okay, and then it's the semi-random telegraph signal. So the definition is like this: the xt is equal to 1 when the k is even and in the internal 0 to t, and xt is equal to -1 when the k is odd and is in the terminal 0 to t. And also we got the first order probability methods like this, and the mean value is equal to this, which is related to the time, and the autocorrelation part is equal to this. So, well, in the semi-random telegraph signal, the probability is when the xt is equal to 1 is not half, because we start with the positive 1. So it means the the probability should be a little higher than the 1/2. So when t goes to the infinity, which means the expect value will be 0. So that will be matches our expectation. And when the t1 minus t2 goes to infinity, the autocorrelation will be go to 0. So which means when the t1 and t2 are far away, the xt1 and xt2 are less correlated. And the 5th part, the random telegraph signal. The definition is the yt is equal to alpha alpha xt, where the xt is actually this is a, so the yt is equal to a yt xt, where the xt is a semi-random telegraph signal. So we got the mean value is 0 and the autocorrelation is this. So for the autocorrelation is similar to the semi-random telegraph signal. That means when the t1 and t2 are far away, the xt1 and xt2 are less correlated. And the mean value means that we can see this image that the mean value shows that the probability that equal to 1 and the probability that equal to -1 will be equal. And so they cancel each other, so the random value will be 0. The mean value will be 0. And then it's the random walk part. The random walk is defined like this, and the mean value is 0 also. And the autocorrelation is equal to the minimum of n and n times the s squared. So so when the n goes to infinity, we will have the Gaussian density, because when the n is equal to the infinity, this part will be the n, and also in this part it will be 0. Oh well, it will be negative infinity. And the autocorrelation function contains the term that comes from the property of independent increment. And for this part is the winner process. So we got the WT is equal to the limit that satisfy these conditions, the xt. The xt is the random walk. So we got the mean value that is equal to 0, and the autocorrelation is similar to this. It's also a minimum value times alpha. Okay, that's it.